Continuing from a previous video where we looked at numbers 1 to 6, which involves more about luminous objects and how they actually produce light, and a little bit about non-luminous objects and pigments. In here we're going to look at number 7, which is how do we see the colors of following opaque objects listed below. Use the words like pigments, primary colors, absorbed and reflected while explaining. Now, drawing can be helpful in this particular question, and this here we have 4 different objects with different colors, and we need to be able to identify which ones are actually pigmented colors versus those that are actually luminous objects. Right now, looking at the other sides of the words right here, we see that they are all objects, and we know that objects that are actually opaque, judging from these ones right here, they don't produce light. So in that case, they contain pigments that are actually involved in absorbing and reflecting light. So in here we have cyan. Cyan, we know, is when we have light coming from a specific source and the light contains the green, the blue and the red. What we notice is that once it touches a cyan genes, in order for we to see this particular genes as cyan genes actually absorbs red color and then reflects green, which I'm going to show here, and blue. So once it reflects both colors, what we see is a combination of green and blue in our eyes, and in our brain actually interprets it as cyan. So in this case, for the next question, which is for yellow, what happens is that once incoming light approaches a yellow car, what happens is that this yellow car absorbs blue and reflects red and green. In our eyes, a combination of red and green in our brain results in the formation of yellow, which is what we see as yellow car. Next one is a black pen. Now, if you have all the secondary colors of pigments actually coming from a specific luminous source and touches black pen or any black object, this black object actually absorbs all the luminous light rays, and there's nothing that reflects back at your eyes, so you are actually seeing black in that particular case. So we know black actually absorbs all luminous primary colors, and that results in we being able to see the color black. So the next and final one is white shoes. We know that white objects, they actually reflect all the colors back at you, and the combination of those colors results in white. So if you're trying to illustrate that, you just put in your blue, your red and green bouncing back at you, and the combination of all 3 colors using all the 3 cones in your eyes results in an interpretation which is white shoes. So that leads now to number 8, which is being able to apply the concept of transmission, reflection or refraction in various mirrors or lenses. Now in here we see in the first one we have a plane mirror, which is straight and it's a plane, and we can just write this as plane mirror. And looking at this plane mirror, we see 2 rays actually created here. We have an incident ray, and this incident ray is noticed to actually create a particular angle that is joined with this particular line, invisible line right here. This invisible line is called normal, and the normal is actually determined by just the line that is perpendicular to this particular plane mirror. So this creates an angle of 90 degrees, which means that it is perpendicular, and this one side of the angle, which is the space between the incident ray and the normal, is called I, which I means is the angle of incidence. And on the other side, once this light particle bounces off this mirror and creates another angle between this ray that is coming out to your eyes and this particular normal. This ray right here is called the reflected ray. The angle between the normal and the reflected ray is actually R, and R is called the angle of reflection. Now this is actually a little bit of a follow-up to this particular next diagram here, where we see this particular curved mirror and we have the slash lines which is on the left side, and also we have a little bit of a hint which shows that there is a ray, incident ray, and this creates a bounce that results in the formation of a reflected ray, and this reflected ray actually touches F, which is called a focus, and this particular ray shows that this mirror is actually called a converging mirror or concave. So concave creates a converging ray situation that actually makes our particular ray to touch the focus, and this particular point here, which is C is considered to be the center of curvature of our particular mirror. And by default, this line that is actually symmetrical to this particular mirror is called the principal axis. These are just imaginary lines that we see, but at the same time, when you're looking at the mirror, you actually notice them as you're moving away from the mirror or you're moving close to the mirror. Now the next one is the other opposite of a concave mirror, which in this case here we see the ray bouncing away from this particular ray, and what happens is that this creates a diverging ray situation. So the creation of a diverging rays is actually by default make this mirror here to be called a convex mirror. In this particular type of mirror, you're actually looking at yourself, but then you're able to see your surroundings, compared to this one, which is more or less restricted. So this is a convex mirror. The one at the top here is called a concave mirror. So the next one here is now looking at lenses, where we see two. On this particular part, we see the rays coming in and doesn't make or touch or passes through the focus, but however they do diverge away. So this particular type of lens is actually called a diverging lens, while by default this other lens where you have the thickness at the center really thicker than the one at the top here, which is less thick, however is narrow. This one right here, which has a thicker center, and the rays that is coming in from the particular left side approaching the center and then converges inward into the focus, actually shows that this is actually characteristic of a converging lens. So that's about it for this particular part. On our next point, we're going to draw images of various objects related to the image, and also we're going to look at a little bit about what is called refraction.